Alrighty, so an object of mass, 1.5 kilograms, tied to the end of a string. It's 0.5 meters long and it's swung in a horizontal circle. Now, I will tell you that you need to differentiate between horizontal uniform circular motion and vertical circular motion. Today and tomorrow, we're going to deal with just horizontal. Vertical, as you can probably imagine, will involve what else? Gravity. Okay, so we'll deal with that Wednesday. Such that it makes 5 revolutions in 4 seconds. And you are asked to find the frequency, the period, the speed, the centripetal acceleration, 2 different ways, and the tension in the string. All right. You guys have this from Friday?
Yep.
Yeah? Okay, so what does frequency mean? We haven't really talked about that a whole lot. So frequency is, do you guys know what period is? Yeah, so period is how long it takes for one rotation. Frequency is the number of cycles per, usually, second. When you talk about how fast your computer is, right? In, I guess it's gigahertz now. I don't want to date myself, right? When it was megahertz, which was like, I mean, to date yourself doesn't mean to go out for supper by yourself or go to the movies. Doesn't mean that. Okay, yeah. I think that's probably wise, Shelby. All right, so anyways, when you talk about the speed of a computer, that gigahertz, they're talking about the number of processes per second. So that's the frequency. In fact, the unit hertz, Hz, is the unit for frequency. Megahertz is 1,000 hertz, gigahertz, so that's 1,000,000 hertz, right? And it's much like the car rental place as well. So anyways, so the frequency is, F-R-E-Q, is equal to the revolutions per second. Frequency is revolutions per second. So we're making 5 revolutions in 4 seconds. So how many revolutions do we make in 1 second? Now, if you want, you could go 5 revs in 4 seconds. So we're solving for x in 1 second. And you cross multiply, right? And you're going to get 4x is equal to 5 times 1, and x is equal to 5 divided by 4. Or you can just think about revolutions divided by seconds. So it's just 5 divided by 4. So the frequency here is 1.25 hertz. 1.25 revolutions per second. Okay? And then in B, the period. Now here's a formula that I'm just going to flat out give to you. The period, which we have defined, or we use the letter T, is in fact 1 over the frequency. The frequency and the period are inversely related to each other. They are inverses of each other. So it is just the other way around, 4 divided by 5, or 0.8. Okay, it's, if you want to do it by ratio and proportion, it would be 5 revs in 4 seconds. So how long x for 1? You cross multiply, 5x equals 4, x equals 4 divided by 5.
So why does 1 equal 4?
Why does 1 equal 4? It's 1 over f, so it's the inverse of 5 over 4. You just flip it upside down.
Would the unit be seconds?
And the unit would be seconds. Correct. Good. Okay? So sometimes they give you the frequency, sometimes they give you the period, and you got to be able to sort of convert them back and forth. So that's why I throw that in there. I asked you to find the frequency period just so that it reminds me that I have to talk about that more than anything. Okay? So is that reasonably comfortable? It will take a little bit of practice. Okay, so C, the speed. So we're solving for velocity, right? And the velocity here, we're going in a circle. So distance over time, let's just sort of think this through here. When you go in a circle, what is the distance traveled? Circumference, or 2 pi r. And the time is, in fact, the period, right? So in a circle, the velocity is 2 pi r over t. And the radius here was 0.5 meters long is the string. And the period was that 0.8. The radius was given in the question. Yeah, it's tied to the end of a string 0.5 meters long. Sounds good. Part D is asking for the centripetal acceleration 2 different ways. And the reason that that is there is because you have 2 different formulas. You have A equals V squared over R. Fortunately, I just figured out the V. 3.93 squared divided by R 0.5, which is 30.9 meters per second. Now that seems like a pretty big number, doesn't it? Why is it so big, do you think? Are these things accelerating that fast? Remember, the speed is changing. What's causing the... Why is there acceleration? Because you're changing the direction, right? And you're a fairly rapid change in direction. Like from one side of the circle to the other, you're making a literal complete 180, right? You're changing the direction a lot. So that's why the acceleration is substantial. Now, did you get the second formula for centripetal acceleration the other day? I think I gave it to you. Do you remember anyone have it handy what the other one is? It's the one with the K in it. Yep, that's the one. Now the benefit of this one is you'll notice that it doesn't have velocity, right? This one here, I had to do this intermediate step. So I could have gone straight to this one because I think I have everything I need. And again, I caution you, the pi is what's squared, not the r. 4 pi squared, the r is 0.5. T squared, t is 0.8 squared. And we're getting into some fairly serious calculator skills here now. Right? Like you're, well, no? Right? So you do have to be, well, you have to be reasonably proficient with a calculator. So you should be able to do it all in one step. 4 times pi squared times 0.5 divided by 0.8 squared, and make sure you hit equals at the end. Which, and you should get the same number as this, right? Yeah, I get 30.84. Yeah. Why is it slightly different? Well, remember we did an intermediate step here, and I probably rounded that 3.93, right? Okay, so again, you could use this one and not have to do that intermediate step. So your choice, I guess. It depends on what you've got in the question, too. Alrighty, one last step. And now they're asking for the tension in the string. So we have to do a little bit of sort of logic here. Well, when you've got something hanging on a string, right, the tension in the string is equal to the what? The weight force, right? So in this case here, the tension in the string is equal to the centripetal force, isn't it? Right? Now I'm going to show you 3 different ways to come up with that centripetal force. Shall we start with the easiest first? Okay. Carter? Oh, sorry, I'm not sure. All right. So the simplest way to find centripetal force, Fc is equal to ma. Right? If the F is centripetal force, then you can plug it into F equals ma as long as the A is the centripetal acceleration, which we have 2 versions of, right? Let's pick the 30.9. So the mass of this object is 1.5 times 30.9. And I use 30.8 here, so that was smart of me. You're probably going to get something a little different than that, but probably a little higher. Hannah's going to help me out.
46.25.
3.5?
Yeah.
We'll say 4. All right, 46.4 newtons. Now, doing it that way, you would have had to have done this, and you would have had to have done that, right? So there's 2 steps prior to that. Remember also that I gave you this formula. I said that also Fc is equal to mv squared over r, which in reality is the same as this, right? It's just sort of, you don't have to write this one out. So it's m 1.5 times v squared 3.93 squared all over 0.5, and you should get virtually the same thing. It all kind of depends on what you've got so far, right? And then there's this one as well. Fc is equal to m 4 pi squared r all over t squared. Remember the good old days with the magic triangles?
I wrote that on the test.
Really?
Yeah.
Me?
No, Mr. Mason.
Oh,
That's funny.
I would accept that. So I've given you sort of a few different ways to get to places, right? Sample number 2. I'm just going to read it out loud to you here. A string can withstand up to 7.5 kilograms hung vertically on it, and then it will break. A piece of string 4 meters long is used to whirl a 2-kilogram mass in a horizontal circle faster and faster until it breaks. Find the breaking force of the string, the maximum speed reached before breaking, and the period of motion at break time. So you'll notice that there's actually 2 masses mentioned in the question, right? There's the 7.5 kilograms, and then there's the 2. So what's the deal here? What's going on? No, that's a good guess, but, right? Yeah. And I kind of led you into that a little bit when I talked about this here, right? So when it says that it can withstand 7.5 hung vertically on it and then it breaks. So we're going to use this to find the tension, the amount of force that string can withstand, right? If you go fishing, there's different test lines, right? What does that mean? Parrot, what does that mean? You got a 10-pound test. Yeah, you should be able to hang a 10-pound fish on it, and then it will break, right? Or it will break anything over that, right? So we're using this to sort of figure out what is the strength of the string. So we're going to go Fw is equal to mg. 7.5 times minus 9.8, or 73.5 newtons. The string will withstand 73.5 newtons before it breaks. Okay, so on the last question, I said, watch out for the word horizontal. Well, here's the word vertical, but is it a horizontal or vertical circle? Right? It's a horizontal, right? So you can't just skim and read quickly, so be careful. Okay, so part A, breaking force of the string. This is part A. This is the breaking force of the string. 17.5, that's the breaking force of the string. Find the maximum speed reached before breaking. The maximum speed or the velocity when it breaks. I got the mass. I got the force, this one right here, right? So we're going to use mv squared over r. So the maximum braking force, or the minimum braking force, I guess, is 17.5. Which mass do I use? The 2, because that's the one that's actually making the circles. We're solving for v, and the radius here now, it's 4 meter long. It's crazy long. Okay? Some I won't say advanced, but certainly some less than beginner algebra skills here, right? Can you solve, you can't solve it in your head, but can you tell me what V equals? Can you do the math here? I hope you can. At this point in your math career, you should be able to. So it'd be 73.5 times 4 divided by 2.0 and take the square root, right? What'd you get, Shelby? 12.1 meters per second. And if you have to do that in a couple steps, that's fine too. Okay, last part, period of motion at break time. We came up with this formula, V equals that 2 pi r over t. Oh, did it again. And there I tend to use the small one for some reason. I don't know why. Just have it. .08 seconds. That's not too bad for degree of difficulty. Oh yeah, there's definitely, I mean, there's going to be ways that, right, every question's sort of unique. So I gave you the sheet on Friday. I think either I see Blair's got it out. This one here. Okay, so, oh, no code on the back.
What shall we ever do?
I don't know, I'll look. I know I have it. That's the one there with the old record player. You guys ever actually seen a record player work?
Yeah.
Yeah? Brown's house? I think I might be able to find it and post it to Zoology here. Let me see.